is the homework, and I'm just going to kind of slowly go through the whole thing. I'm not going to give you all the answers, but I'll kind of guide you to the right spot. A lot of these questions connect to the questions from before. So let's start with problem 1. It says quadrilateral ABCD is dilated with the origin as the center of dilation, moving point B onto point B prime. What is the scale factor of the dilation? Pardon me. If we're starting at O, at 0, 0, which is our center of dilation, and I know what B prime is, sorry, I have the hiccups. I can figure out what the distance between O and B is in order to figure out what the scale factor is. So I know, looking from O to B, that I go up 2 over 2. So if I go up 2 over 2, that's 1. Up 2 over 2, that's 2. So then my scale factor would be 2. So when I submit that, I go on to the next part and I say, okay, my scale factor is 2, so I have to now draw my quadrilateral. So I'm going to just take my points. If B prime is 4, 4, and that's going up 2 over 2 twice because my scale factor is 2, I'm going to do the same thing with A. So I go up 1, 2, 3 over 2, so I'm going to do that again, up 3 over 2, and put my point right there. And then the same with D, I go over 2, down 1, so I'm going to go over 2, down 1 more time. D is right there. C, I have to go down 1, 2, 3 over 1, so I'm going to go down 1, 2, 3 over 1 once again, and there is C. Then I connect my points here, here, and here, and here, and I'm just going to label them quickly. So I have A prime, D prime, and C prime. So this is where I'm at, and now I need to write my coordinates. So looking from O to A, I already know that B is 4, 4, and it doesn't let me put in B. So I know from A, I run before I jump. So I go on the x-axis before I go on the y-axis. So looking here, I go 1, 2, 3, 4 over. So my x is 4, and my x is negative 4, because I go to the left, so that means it's negative, and then I go up 1, 2, 3, 4, 5, 6. So my coordinate for A is negative 4, 6. Now I would do the same thing for D and C. I'm not going to do it because I think you are capable of doing it. I'm going to move on. So problem 4, here's triangle ABC on the coordinate plane using the origin as the center. So an origin is always 0, 0. And the scale factor of 2, drag the points to make triangle DEF, the dilation of triangle ABC. So I know that if the origin is my center, to find out where C prime goes, I have to go over twice and up twice 2 times. So I do 1, 2, 1, 2, 1, 2, 1, 2. So I'm going to put C, or I guess in this case it would be D. Or actually, I guess it would be A, B, C. So then D would be A, E would be B, and F would be C. So I start at the origin, I go up, over 2, up 2, over 2, up 2, which would be right here-ish. I'm going to do the same thing. I go down 2, over 2 for B, so down 2 over 2 is 1, down 2 over 2 is 2, so my scale factor is 2. Those check out. Lastly, D, if I have to go from the origin, down 2 over 4, then I do that again, down 2 over 4, so then D would be right there. That should be my triangle DEF with a scale factor of 2, and that seems like maybe it's right. Problem 5, now here's ABC, and instead of using 2 as your scale factor, you're using 1/2 as your scale factor. You're doing the same thing, but putting it here. So now instead of going from the origin over 2 up 2, you're cutting that in half. So you're going to go over 1 up 1, which is where then I would go. Now I'm not going to do the other 2 because I think that you can solve it if I give you at least that much. Okay, go back and complete the previous 2 screens. Well, I've completed this one, so I'm not going to do that one. You can finish this one, so I'm going to let you figure out this one, okay? Problem 7, triangle ABC has vertices located at -3, 3, -2, 3, and -1, 2. Triangle ABC prime is the result of dilating triangle ABC using the dilation center of -5, 1 as the center of the dilation and a scale factor of 3. So, okay, quickly, if we just plot our points, -3, +3 is A. So I'm just going to write A. And then B is -2, +3, which is right here. So tiny triangle. Oops. This is B. And then C is -1, +2. So -1, +2. This is like a super teeny tiny triangle. So let's just connect our points. I'm going to connect them a little better. Like super teeny tiny triangle. Okay, so if our center of dilation is -5, +1, that's -5, +1. It's going to be right here. So that means that every point needs to come back to this point. So I have to use my scale factor of 3 and relate that to every single one of these points. So the distance from O, which is right here, to A is I go up 2 over 2. If I do that 3 times from my center, then I'm going to be able to get my A prime. So I go up 2 over 2 once, up 2 over 2 twice, up 2 over 2 3 times. So my new point A is right here. That's A prime. Then I do the same thing with B. I go over 1, 2, 3, 1, 2, 3 points up 2, 1, 2, 3 points up 2, 1, 2, 3 points up 2. So B prime is right here. And then over 1, 2, 3, 4 up 1, 1, 2, 3, 4 up 1, 1, 2, 3, 4 up 1. So C prime is right here. And then I can connect these, and I have my triangle. Now, I can actually check that my work is true, because if I know my scale factor is 3, I can see if this triangle is 3 times the size as this triangle. And looking at the length of AB, which is 1 unit here, I can see that the length of AB prime is actually 3 units. And I know that 1 unit times 3 units is 3. So I know that this is in fact a scale factor of 3 because I can double check my measurements of my triangle. I can also double check that everything's right, because if I take my straight lines and connect them, I can see that A and A prime, B and B prime, and then C and C prime all connect. Now, obviously, I haven't drawn my lines very well right here, but my dot comes down a little bit more right there. That's where the actual dot is, and then you can see that those do in fact connect. So here's our drawing. I need to now put my new points in. So then I would say, well, if I know that A is -3, 3, if I multiply both of those by 3, I'm going to be able to actually see that, I'm just kidding, because I'm a liar. Because my center is at -5, 1 and not at 0, 0, I can't just multiply. But since I've put them here, I can actually see where they are. I know that my Y, or my A, is at 1, +1, and then I go up 1, 2, 3, 4, 5, 6, 7. So it's going to be +7. And then, oops, I guess it wants me to just get rid of those parentheses there, and it does parentheses for me. So parenthesis, B looks like it's at 4, 7. And then C prime looks like it's at 7, +4. So here are the pre-image and image coordinates of the points on the graph. Describe the transformation. So pre-image to image. If I went from 0, 4 to 0, 12, that means that I'm getting bigger. right? I can see that I'm getting bigger because my even just my first coordinate gets bigger. But then looking at these, I can say, okay, -1 to -3, 3 to 9. That must mean that there's a scale factor of what? 4 times what is 12, -1 times what is -3, 3 times what is 9, 5 times what is 15, -6 times what is -18. So I know what the scale factor is just based off of the relationship between 4 and 12. So I can say the scale factor is ... I'm not going to tell you what it is. I want you to figure it out. I know that the image will be blank than the pre-image. I put the blank there because I want you to tell me, is the image going to be bigger or smaller than the pre-image? Okay, so then you can submit that whenever you answer that and move on. So this is spiral review. Use what you know about the interior angle measurements of triangles to complete this problem. Triangle JKL is a right triangle, and the measure of angle J is 28 degrees. I know that a right triangle looks like this. Okay, so this part is here, and let's say this part is 28 degrees. You're now trying to figure out what this is. So if this is J, K, L, you need to tell me what is K and what is L. Okay, triangle PQR is an obtuse triangle, and the measure of angle Q is 72 degrees. What are possible measures of the other two angles? Well, if I know that it's an obtuse triangle, that means that this angle right here is going to be more than 90 degrees because that's an obtuse angle. So if this is more than 90 degrees, and let's say that this one right here is 72, this is Q, this is P, and this is R. P, Q, R is our triangle. What could angle P be? Well, angle P could be anything more than 90 because an obtuse angle is more than 90. So if, let's for example, say that this angle is 91 degrees. We know it's more, but let's say it's 91. That's an obtuse angle. What would R be? You know that an entire triangle has to add up to what? With that information, I want you to just put in a guess. This one can be a lot of different answers. Okay. So then here is this. So now obviously some of these are incomplete because I didn't finish them, and I think that you are able to finish them. These ones are, say, completed, not correct or incorrect because they're typing or they're drawing. I have to go in and actually do those. So that should give you enough information to then guide you to finish the rest of the assignment. Thanks.